Welcome student. Today we are going to study about this critical depth or some terminology that is used in specific energy curve. In last lecture we have discussed or we have studied about the specific energy and specific energy curve, right? So in specific energy curve there are different terminology used that these terminology are nothing but this critical depth, critical velocity, right? And minimum specific energy. So today we are going to study about this terminology. What is the meaning of this terminology, right? So the first term, that is nothing but critical depth, that is used in specific energy curve. Yesterday we have discussed about this specific energy curve. So this curve A, B, C is nothing but specific energy curve, right? So there are some terminology that is used in this specific energy curve. So yesterday we have discussed about the how to draw this specific energy curve, right? Now first terminology is critical depth HC. Now what is this critical depth HC, right? So it is defined as that the depth of the flow of water at which the specific energy is minimum, right? As we know, specific energy curve is nothing but it is the variation of specific energy with respect to depth of the flow, right? So this is nothing but this is your specific energy, right? So at a particular point, if you see this point C, right, at this point, if you observe about the specific energy, so at this point the specific energy is minimum, right? Now what is this value at this is a minimum value, that is nothing but E minimum, right? So corresponding depth of the flow, this is nothing but your critical depth HC, right? So what is critical depth? It is nothing but, right, so it is nothing but, or it is defined as the depth of the flow of water at which or at that point the specific energy is minimum, right? So that is called as what? Critical depth HC, right? After this, now we have to derive that, we have to find out what is that critical depth SC, or what is the equation of SC, right? Now we know what is specific energy. E is nothing but V square by 2G plus H, or you can write H plus Q square by 2G into H square. This is equation number 1. Yesterday we have derived this equation VH plus Q square 2G into H square in order to draw the specific energy curve, or in last lecture we have derived this equation, right? Now as we know, for critical depth HC, the specific energy is what? Minimum, means this energy is minimum. So for minimum value of this energy, so that is nothing but E minimum. So how to find minimum value? That is nothing but we have to find out the derivative of that this energy with respect to variable term is H, that is dE by dH is equal to 0. That is nothing but slope is equal to 0. So dE by dH is equal to 0. Now means take the derivative of this equation number 1 with respect to H, right? Now therefore d by dH. Now what is the equation of energy? Now this is the equation of this or this. You can take this, we can take this, right? So H plus Q square by 2G into H square in bracket is equal to 0. Now take the derivative of this, right, equation with respect to dH, that is d by dH of H plus Q square by 2G into H square is equal to 0. Now variable term is H. Now what is the derivative of H, right? Now derivative of H is 1. After that, this Q square 2G, take it common because it is a constant, right, into, so the derivative of 1 upon H square, right? So that is nothing but minus 2 into 1 upon H cube whole bracket close is equal to 0, right? Now how we have find out this 1 by H cube? What is the formula is used in order to take the derivative of this 1 by H square? So the formula is nothing but d by dx into x raised to power n. So we have used this formula, that is nothing but n into x raised to power n minus 1 into dx. Derivative of x raised to power n is equal to n into x raised to power n minus 1 into dx. So that is x is nothing but 1 upon h square. So therefore if you take h square on right, numerator, then h square, that will be h raised to minus 2, that is nothing but c here. So 1 upon h square is nothing but, that is h raised to h raised to power minus 2, and therefore d by dh of what? H raised to power minus 2 is nothing but, that is this same formula that we have used, right? That is nothing but that we have to use this is nothing but, what is the derivative of this h raised to power minus 2? That is nothing but minus 2 this n into x raised to power n minus 1, that is h raised to minus 2 minus 1 into dh. That is nothing but 1. So therefore minus 2 by h raised to power minus 3. So therefore if you take this h raised to power minus 2 to the denominator, so what is the term? That is h raised to power minus 2. So what is the derivative of this 1 by h square? That is nothing but minus 2 by h cube. Okay, so therefore we can write that derivative of this 1 by h square is nothing but minus 2 into 1 by h cube, right? So this 2 will cancel, right? Remaining term is 1 minus q square by g into h cube bracket close is equal to 0, right? Now take this term to that side, so that will be plus. So 1 is equal to q square by g into h cube, right? So therefore h cube is equal to how much? Q square by g, right? Now take the therefore from this h is equal to how much? Q square by g bracket close whole raised to 1 by 3, right? So therefore h is equal to q square by g whole raised to power 1 by 3, right? Now after this, right? So now after this, therefore, right? So as we know, so this we derived from that minimum that specific energy, and we have used that condition of minimum specific energy. So therefore h becomes hc. Therefore hc is equal to q square by g bracket close whole raised to power 1 by. So this is the equation of critical depth. That is nothing but hc by q square by g whole raised to power 1 by 3. Now this is about what? Critical depth, that is hc. So if you want to find the hc or critical depth, so we have to use this equation q square by g whole raised to power 1 by 3. So this is very important in order to solve the problems, right? Now next terminology that we have used in we have seen that terminology in a specific energy curve, that is the critical velocity. Now what is this critical velocity? The velocity of flow at the critical depth is known as the critical velocity. Means what? So the velocity corresponding to that minimum what depth means what? Now this is our specific energy curve, right? Now so corresponding to this depth of hc, the depth of the flow, so whatever the velocity of that flow, so that velocity is called as what? Critical velocity, which is denoted by vc, right? So vc is nothing but it is corresponding to hc, that is nothing but critical depth, right? Now similarly we have to find out now what is the equation of vc, the critical velocity. Now expression for critical velocity, right? As we know, the critical depth hc is equal to how much? Q square by g bracket close whole raised to power 1 by 3. So just we have derived that equation, hc is equal to q square by g whole raised to 1 by 3. Now taking the cube on both sides, if you take the cube, so what is the equation? hc cube is equal to q square by g. So we will get this equation, that is hc cube is equal to q square by g. By taking the cube on both sides, so we will get this equation, hc cube is equal to q square by g. Now therefore now what is q square? That is g into hc cube, right? So this is equation number 1. As we know, but we know that this small q is nothing but your specific discharge. So what is specific discharge? That is capital Q by small b. So this is specific discharge, that is nothing but discharge per unit width of the channel, right? So therefore so small q is equal to capital Q by b. So as we know, this discharge is nothing but a into v, where, right? So therefore that small q is nothing but a into v into b. So discharge capital Q is nothing but a into v divided by b, right? After this, as we know, area of channel is nothing but b into h, or area flow of that channel is nothing but b into h into v divided by b. So this b will cancel. So what is the remaining term? So q is equal to h into v, right? So therefore so now what is this h and v at that minimum specific energy? So that is nothing but sc and vc, right? So therefore q is equal to hc into vc. This is equation number 2. So this is equation number 2, that is q is equal to hc into vc, right? Now so put this equation number 2 in equation number 1. So this is equation number 1, q square is equal to hc cube into q. We have just find out the value of q, that is hc into vc, right? Now put the value of q in equation number 1. So therefore now this that equation number 1 is nothing but q square. So q square is nothing but, so hc square into vc square is equal to hc cube into g, right? So this hc square and hc cube, this cube will cancel. So therefore what is the remaining term? Vc square is equal to hc into g. So therefore So VC square is equal to what? HC into G. Therefore, what is VC? Now if you find VC, so what we will get? So VC is equal to how much? So this is your VC, that is VC is equal to square root of G into HC, right? So just we have found VC, that is nothing but last equation is VC square is equal to G into HC. So if you take this square on both square root, therefore VC is equal to square root of G into VC HC. So this is the equation for the critical velocity, that is nothing but square root of G into HC. So this is also required in order to solve the problems. So in order to find the critical velocity, right? Thank you.